Okay. All right, we're in. All right, we're back from the break. Shop Class Podcast. Welcome back. And we got a good group of people here. We are stoked off of a massive endorsement from Brant Taylor. Say hi, Brant.
Hey, gang. Glad to give shout outs on my recent podcast with Mike Kanoki at the Contracting Handbook. It was a really good conversation. And we talked a lot about next generation and what to do with them when they get just appropriate to give a good nod to the people who are making that next generation and their future happen. So Shop Class Podcast is on the rise.
Yes. Awesome.
Hey, Brant, I liked how you said you've been hanging out with the Shop Class Podcast on Wednesday nights. And think of like back in the day, you're hanging out with your friends. You're right next to them. This is hanging out now.
Exactly right, man. The more people who can join in this, the better. And there's a good conversation that's happening here. The dialogue overall and the undertones of the dialogue, all of this is where I choose to spend my time here for a reason. There's a value in this future. So this is one of the highest stakes and highest value futures that we have to consider right now in our country and in our world and in our landscape. We've got to be putting our energy into our children. So I'm on board 100%. I want to support you guys and give back any way I can.
Yeah, I'll take a line from the Hammer app. You guys were talking about the Hammer app as well. And they said they always post things like creating the next generation of legends. And I love that when they say that, because that's what these kids are going to be. You know, you're in your department always has a legend. You know, your construction crew, your builders, there's always that legend you talk about. So that's what we're doing. We're molding our next generation of legends.
Oh, absolutely. That is awesome. Yeah, and it's so cool. Like, it's like better late than never. Like, because I'm one of the people that grew up without a shop class, and now I'm talking with people that are trying to support the shop class and do support, and I'm just like, wow, this is like awesome, you know? So it's very cool for me to watch this whole thing unfold, you know, and the support is unbelievable, you know? Let's see. So now I have the link here if someone wanted to listen to that podcast. It's right here. So if you went to, first you go to Mike Kanoki, I think I'm saying it right, and then he's got the Instagram. And basically he's a general contractor that is now writing books about how to do this, you know, after years and years and years of analyzing it. And he's got this link tree. Obviously, the link tree is a good thing because you could get all your links going. And one of the first links on there is Brant Taylor, the tool hacker. And we have our own podcast with Brant as well. And then so you go here, and obviously there's the energy. It's awesome, Brant. It's so much fun listening to you. So, and you don't even have to log in or anything. You just click on listen. I think I don't know where the button would be on the PC version, but when I was on the phone, I just clicked listen. So it's on all the stores or whatever, you know. But that's what they're talking about. Yeah.
It does Mike a lot of good. He's an up-and-coming podcaster. This is now his second season. I think he's got 13 episodes out total. He's got a bunch more recorded that he's going to release this year. He's got some really good talent on there. It does a lot of good for his listenership and for his rankings for you to leave a review on iTunes. So if you enjoyed the episode and you got something from it, whether it was encouragement or motivation or information or knowledge, please leave a 5-star review on iTunes. Help him climb the ranks. He's a qualified and experienced voice who deserves to be elevated.
Okay. So, and is iTunes Apple Podcasts, or is that something else?
Oh, I think you're right. I think that is the Apple Podcast. Yeah.
Okay. I gotta check it out. Okay. Cool. And there's a million ways to listen to it. But that's good. Yeah, we'll definitely gotta leave a review. It's nice. He does a good job. He keeps it going, and he's got good questions. The other one, I listened back to back. I was at the gym, and I finished one, and then I was like, I had actually time, so I was like, you know what? I'm just gonna do another set of the pedaling on the bike, and I'm gonna listen to this one. And this is Brittany, and she's a framer, and then she has her own company. I think she actually is her day job as a framer, and then she actually has another contracting company that she works on afterwards. Which is there it is, so you can listen to it.
Is she from Australia?
No, but it looks like it, right? I don't know.
I was listening to one too. I was blowing leaves, and you can knock these out pretty quick because a lot of them are pretty short. You know, like they're under an hour.
This one is Robin Clavette, I guess. Yeah, I don't know where the Australian one was. No, she sounds American. But these are great, you know. Which one did you listen to, Duke?
I don't know. There's still leaves on the ground. I forget.
That's funny. All right. So, and then obviously, I got to listen to this one. Steve Basic. This guy's awesome. He's great at like getting to it. Like just get straight to this. I feel like he uses science like a hammer. He like smacks you in the face with it. You know, it's amazing. And they're building these houses, and they're just talking about the energy envelope and the process of doing that. And I like that you guys that Brant addressed. You know, like something was kind of interesting was he talked about how there's he puts a hunter's camera on the dumpster to watch the junk being thrown out at a job site.
The waste.
Yeah.
That our kids are going to be left with cleaning up.
Yeah.
Yeah, I put up a post yesterday about that. I just felt compelled to talk a little bit about the legacy that we're leaving. You know, Mike's doing a very good service to the construction industry. Our industry is really just starting to find its voice and just starting to figure out how to communicate. You think about it, when we go away to these home building job sites like Matt Bloomquist works on, you're leaving civilization to go somewhere where there's not civilization and establish it. That daily disconnection from the rest of the world creates like a mindset of a daily time frame that you're going to be disconnected from the rest of what's going on. So the fact that the construction community is starting to come together and actually have a worldwide construction tribe, they're actually starting to like establish network and establish this communication. I know it seems like, Brent, you're just talking about social media. Yeah, sure, but a lot of construction is not participating in that wholesale. So it's a big deal that guys like Mike are stepping forward out of the woodwork and saying, you know what, I think I can build more than just a house. I think I can actually build learning for other people to pick up on. I think I can build a book. I think I can build a legacy of knowledge and education and the open source sharing of ideas. And that's a big deal. You know, when he has guests on there like Steve Basic, the construction world listens to that leader and to that icon. And when he talks about standing up to bad customers and turning away bad money contracts, that emboldens new business owners like Brittany Farrow and like other people who are out there to embrace that strength, and they grow stronger as their own business. It builds resilience inside the trades. All of these investments that these people are making verbally and vocally into this effort are crucial. They're crucially important to our industry because we're on fragile ground. We're on fragile footing. So it's important that we get solid footing and solid stepping as we march into the future. And these people are paving the way for that to be possible.
This is amazing. That's the Brant energy right there, man. It's so cool. Like, you know, and it's kind of goes hand in hand with the missing shop classes and how the shop teachers are coming together as well. And I like that the shop teachers are talking with the tradespeople and the trade. You know, like for instance tonight, Chris Hernandez, he's working in the industry. He's a hands-on guy that's got an engineering degree, and he's willing to talk to the shop teachers because he knows, hey, the next generation's coming up. We got to talk about this. You know, pretty cool. All right, so let's get it going here. Introduce the guests. We got Chris Hernandez. He's His nickname is Chris Rocky Hernandez. I'm sure there's a
Yeah,
story.
you guys can call me Rocky. Yeah.
All right. And yeah, so we always start with the first question. I always ask every guest we have on the show. Did you have shop class growing up?
Absolutely, 100%. And
Nice.
started in about 6th grade, and it went all the way through. So I remember, it was 7th grade. We started doing lost foam aluminum casting, and we built toolboxes using sheet metal and spot welding. We built gumball machines out of wood. We made our own tools. So like my shop teacher had us learn about injection molding, and so we would make our own screwdrivers, and then we'd make our own screwdrivers, our own adjustable crescent wrenches, and then using die casting, and then we'd build like a very fundamental set of tools, build a toolbox, and then you'd carry that toolbox with you, and you'd use those tools all the time, like throughout the rest of the shop class. And
Wow.
so we built all kinds of stuff, acrylic baseball card holders. And this was in junior high.
Wow.
And then moving into high school, lots and lots of auto shop, body work, engine rebuilding and welding, machine shop. In fact, when I moved here to Tucson, the teachers were very open to, if you finished your work and you were good to go, like for example, typing or Spanish class or something like that. If you did all the work and your grades were legit and you were done for the day with the activity that you had to do in class, and you asked, can I go to the auto shop? They'd let you. And so we would go, and I would spend.
It sounds
and
like
I had
so
good
much
grades.
fun.
Yeah, so I had good grades, and I did well in high school and middle school and all that, junior high. And so they didn't have a problem with it. Now, if you were not doing well, they wouldn't let you do that. But so, I would bring my car. I drove my car every day to high school, and then I would eat lunch and then go to auto shop. And then I'd go to Spanish class, finish up, and then I'd go to auto shop. And my auto shop teacher was awesome. He showed us how to build potato cannons, and he was a hunter. So he would bring in all kinds of stuff for us to like javelina heads and stuff, and like show them off. And he was just a wild guy, but he would allow us to do a lot of stuff, allow us to explore in a safe way, right? He wasn't letting us, light fires and be crazy. But if you had an issue, or if you had an idea, like if you wanted to build a crazy car or build some weird thing, and he would totally help you, absolutely help you. And I think that was the best thing about it, was that the teachers would enable us. They wouldn't tell you, no, you can't do that, or that's a stupid idea. No, let's just do this little project instead. They would listen to you, and they would teach you the fundamentals. And then if you had an idea about maybe things you wanted to build, they would let you do it, and they would show you how to do it.
Wow.
Some of them would take you as far as to showing you how to do it, and then watch you fail, or watch the project not quite work out, and then, okay, well, now what? And try to help you kind of move along. So yeah, I had shop class all the way through high school, and then even moving into college. I went to Pima Community College, which is basically a trade. I went and studied automotive technology and welding and machine shop.
Mm-hmm.
And so I wasn't really sure what I wanted to do. And so that just kind of, I knew I liked shop class. I knew I liked building things and making stuff. So, and fixing cars and building cars. And so I did that in college, and turned wrenches for a living for a little while. And then when I went on to university, again, the only reason why I stayed and enjoyed university and engineering school was because I got involved in other programs that were there. So like the solar car team, I think there's some pictures of the solar car on my Instagram there. And they were like, I would sleep in that auto shop where the solar car was being built. I would show up there, I'd go in Friday night, I'd come in Saturday morning, I'd do homework, then I'd come back Saturday night, come Sunday, and we would work on that solar car all day long for 2 years. We had to fundraise, design,
Is this it?
build. Yeah, that's it right there. So it's called the American Solar Challenge, and I competed in 2 different races. So every 2 years, you would build a car. So you fundraise, you design the car, then you build the car, then you race it from Chicago to LA along Route 66, and that was awesome. That was no kidding. The reason why I stayed in college was that car right there, and then it was one before
Wow.
that, and I learned so much there. Not just about engineering and about manufacturing and building stuff, but also about myself. You know, when you have to live and deal with this group of people for that many years, and everybody's got different ideas, and so that was a great experience. It's kind of funny going back to what you guys were talking about, you know, mentoring and kind of giving back to the community or to the next generation. You know, that was exactly what I was posting right here. Was, you know, making sure that you go and you do stuff like that, because you know, that guy there, Dunbar Bernie, was our advisor for that particular
He's in New Jersey now.
project. Yeah. So he left U of A, and so he was our advisor, and you know, he would just kind of help us out when we needed help, but he would, for the most part, just let us kind of go. And you know, I spent many hours working on that car and getting it
Wow.
running and doing all that, and then to watch it go from Chicago to Los Angeles was unbelievable. It was actually a time when we first started that race, we were in dead last because our car wouldn't start. It wouldn't run. So everybody leaves in waves. So we were in kind of the last group to go because we qualified near the back of the pack. They say, get ready, get set, go, and go. We take off, and it dies. The car immediately dies.
Oh man.
And so we were in dead last. We got it running. We move about 20 miles, and over the radio, we're using CB radios. We hear that there's a chip sealed road up ahead, and that all the solar car tires were going flat on the chip sealed road. But because we were last, we were able to learn about that, and that literally everybody was getting flat tires because they were just trying to get
Is
through
this
it.
it right here?
That Turbulence was the one I worked on, and I also worked on Monsoon.
Wow. This is so
And
cool.
so we walked up to the chip sealed road, and just like we would think, a chip sealed road is very sharp. The little shards of rock are very sharp. So we were kind of like, well, what do we do? Do we just go through? Obviously, everybody's getting flat tires, but we wound up, because we were sponsored by 3M, we got a whole box roll of duct tape. So we wrapped all the tires in duct tape, like one roll per tire. And we went from dead last to 10th, just
What?
like that. And
What?
then we lifted the tires up and took all the duct tape off, and then continued going. We held 10th place all the way for the rest of the race.
Wow.
And so it's just stuff like that where I mean, you would never get a chance to experience things like that. And you know, you literally sleep. I think for 2 weeks, that's how long it took. I think I slept like 4 hours for 2 weeks. I lived off coffee and McDonald's, and you know, I'm not in the military, but from what I understand, boot camp and that kind of thing, like it's very much camaraderie, a lot of just, you're kind of getting through it. You're just kind of grinding, and everybody's tired and hungry and angry and nervous and whatever. But you kind of took this contraption, this death trap that you made for 2 years, and raced it from Chicago to LA. And that was, to this day, one of the greatest things I've ever experienced, ever.
Wow. This is awesome.
And you know, guys like Dr. Bernie, and there was another gentleman, Dr. Arabian. Those guys helped us a lot. And then we had sponsors from the industry. Raytheon was one of our sponsors, Boeing, ANSYS, PTC. So a lot of companies would sponsor us and give us software to use and
PTC,
and tools and machine
3D software.
Right. And they would let us use their machine shops, and you know, like all those parts right there, those were all machined, CNC machined, that we programmed. They taught us how to program them, and then we ran and, you know, bought the billet aluminum and machined them ourselves. Built what we learned. None of us knew anything. We learned how to use carbon fiber and build and mold carbon fiber, how fiberglass works. You know, we
I
painted
like,
that thing by ourselves. I mean, the whole nine. Everything was built by us.
yeah, I like these challenges. You know, racing has a thing. You know, I've gone quad racing, and then I helped out a team go land speed record Bonneville, and there is a something. Well, I don't know how to describe it, but I would say this: you basically have to be prepared at any moment to put out a fire. So you're kind of like a fireman, and you, like you said, military. You're on your own. You're like in. You have to set up the tent, and you got your bring your own food supply, your own energy supply, your own tools,
Right.
and everything is going to get destroyed by the weather. You know, and it was
Yeah.
funny.
So the way that worked, the way this race worked, kind of along those same lines, is wherever you were when the sun went down, that's where you stayed. So you could be in the middle of nowhere, and so we would sleep in the
Oh,
trailer. So you had a
so not only did your pit move, because like when you go, the Baja 1000 is the craziest race of all time, and the pits are never in the same spot, and neither is the race. However, this is what you're saying is like wherever you stop is where you pit. That's insane. That means you got to set up every single night in a different location.
That's right.
So this
Exactly.
is just as crazy as the Baja 1000 then.
Yeah, except it's all on Route 66 and a little bit of freeway. So you have a lead vehicle, then there's your solar car, then there's your chase vehicle. And so you're kind of, racing. The cars don't go that fast because they're solar powered.
Yeah.
But so wherever you pull over for the night because the sun's down, that's where you camp out. And so we would sleep on top of the van. We'd sleep in the trailer. And there was a couple times where we were sleeping near some farms. And there was a few times where like little old ladies would come out and like, what are you guys doing? And they would make us food and give us coffee. And one time they let us sleep in their house. I mean, I don't know how safe all these things would, maybe people would think twice about, but so it was just awesome.
They probably caught the vibe. They're helping you. They understand.
Sure, and it was on TV. They actually had people following the race on local news channels, and so you kind of could get what was going on. But I said all that to say this is, all that came from people like you guys that are willing to help these people, younger people out, younger generations out, to try to show them things that they otherwise may not ever see. I've listened to this podcast before, and I've heard you and others say that they've never had shop class, and there's people that might not grow up in families that also are exposed to things like working with your hands or making things or fixing things, whatever. And if you're never exposed to it, then how would you ever know that you love it? The enabling of these kids is the biggest thing, and my father was great at that. So he didn't work on cars or fix cars or anything like that, or fix really anything other than just kind of general maintenance around the house. He would do like oil changes, things like that sometimes. But he recognized real early that I was really into it. Build model cars. At 3 years old, he would let me heat up knives with a candle to cut plastic to make like custom pieces from my die-cast cars. Friends of ours would teach me this. Older boys would teach me this in the neighborhood or friends of family. And he let me do it. So he said, he gave me a 4x8 sheet of plywood in this 2-bedroom condo we lived in. And he says, whatever, you can do what you need to do. Keep all your crap on that 4x8 sheet of plywood. Don't leave it all over the house. And that's exactly what I did. I built model cars, and then I'd take them apart and then do it again and take it apart, or I'd build Legos and I'd take my bikes apart and repaint them and do stuff. And he totally let me do that the whole time.
Wow,
all the time.
That's great.
And my grandfather did the same thing. He would totally enable me to do all these things that neither one of them really did. My grandfather was a tinkerer. He would fix a lot of things, but he wouldn't really make new things or invent new things or create things. But so that's why when I saw your podcast and I saw what you guys are doing, I thought it was awesome that you guys are, not just not just, going to work and coming home, but it seems like you guys were concerned and really want to do something about it, because the fact that there's not a lot of shop classes around a whole lot anymore is kind of rough to listen to. And because I know for me at least, it was a big deal. That was a massive part of my life, was shop class and doing all the things that I was taught by people like you guys. And I mean, like my son, my older son and my younger son, we've done stuff together, but outside of me, they haven't really had a chance to do much. And so I really think it's awesome what you guys are doing, and I really appreciate it.
Oh, dude, that's great to hear. Thank you for you. I mean, just you coming on and taking the time. This is the support. It validates what we do, and it probably will inspire more people to become shop teachers. Sometimes I get calls from contractors or people that have been in the industry for a while, and then they ask me, like, how did you become a shop teacher? And I can walk them through the steps, and which is kind of interesting. And you don't have to be a shop teacher in a public school to be a shop teacher. You just got to do, like we're saying, like enable people, enable kids. One thing I like what you said, I mean, a lot of things, but something interesting that I think you recognized was that you were allowed to tinker and try creative things. I have found that students that they might have changed the brakes, or they did something in the class, maybe they tried welding or they tried this or that, but it's really the students that got a chance to do something creative, and the creative thing actually had some sort of impact. So I call it a measurable benefit. So we had a baseline, they did something different out of literally from their brain, literally from just coming up with ideas. And then we measured that either through racing or weight or whatever. That is the addiction. Once they've got that, boom, they're hooked, and they're hooked for life. That's it. I don't have to do a thing after that. Once they've got that bug where they got a chance to really see the difference, them being creative resulted in a win. Once they see that, that's it. There's no, and then they're gonna, you can't give them enough stuff. They'll eat it all up. They'll go on to, like you said, they'll go on to do challenges, and at college they'll climb the ladder very quickly, or at a trade school. So I think that's the important part, is allowing that. But it's difficult because you can't just let every kid just do whatever, and you got to have some sort of baseline, and that is the rub of a teacher, is to create the environment that's safe and has some sort of baseline, and then the creativity is on top of that, and they can measure the creativity.
So do you guys have time in your day, or I guess during your class, to do that? I mean, one of the things that helped me was being shown how do these tools work and what can you do with them, and then you build something simple with it, and then it's like, all right, what can I do with this? I mean, how does that work in your guys' curriculum?
So luckily, the one thing that I like about being a shop teacher is there's no state curriculum yet. Especially in my area, I'm not teaching the trades. I'm not teaching what they call a CTE class, where there's wood shop 1, wood shop 2, and wood shop 3, and it's through a Perkins grant or whatever, which is fine. But I don't have a set thing. So what I do is it really depends on the students, because we get waves of different types of students. It's very hard to anticipate what you're going to get. And then you might have a year where the administration fully understands the size of the class compared to the amount of teachers. So I have a 20-to-1 ratio, but then there'll be a year where that gets blown out. It'll be 27-to-1. And I'm like, oh, okay, well, we can't do what I was planning to do. It's impossible, So what I do is I treat them, this is my secret, the way I do it, is I treat them like spies. They're on a need-to-know basis. So basically, First, I'll start with like some paper models. I won't even let them know that we have like metal cutting tools, and I'll just keep it all away. And we'll start by making little paper challenges. We'll get into drafting. We'll make stuff, and we'll try and break some things. Then we'll start getting into electricity. We'll light some things on fire, little by little, get bigger and bigger. And then I bring out sheet metal and we start bending stuff and welding stuff. And they're like, wow, why didn't we do this before? And I'm like, you wouldn't have appreciated it. It wouldn't even made sense to you, So I go very, very incremental. That's my way. I don't know. We got 3 other shop teachers in the room. Duke, how do you
Yeah. Rocky, I'm a middle school teacher. You said you had it always from 6th grade up to, through high school. And that's where we start the kids in 6th grade. And, 6th grade, that's where you hook them, and we start with hand tools and we make the Pinewood Derby Car just like they do in Cub Scouts. And a lot of the kids say, oh, I made this in Cub Scouts. But in our curriculum, it's heavy on the design process. And the Pinewood Derby Car is a great project to do with the kids to teach the engineering design process, because it has it comes up with a problem. You got to design a Pinewood Derby Car that looks nice because you want to take it home to your family or your friends and show them, be proud of it. Looks nice but goes fast. We race it at the end. There's pandemonium on the last day, race day. You're just holding your ears and hoping somebody doesn't run into a shop table. But so then they research their ideas. They come up with some ideas. They develop a prototype. They test it by racing it, and then it starts all over again. If you can build this again, you can draw it. There's a lot of Tinkercad. AutoCAD came up with a nice program for kids to use to implement the design process and drawing with the computer instead of on paper. We'll do sketches on paper. Because of COVID last year, we went heavy on the computers. Because we weren't in the classroom, but this year, the kids can't wait because they've been on the computers for a whole year, and that hands-on aspect of it, working with their hands and logging off, getting offline, they really appreciate it now more. We in 7th grade, we do some robotics, so they're introduced to robotics. 8th grade, we'll do laser engravers, 3D printers, CNC router work. Basically, it's just exposure for me. I have them for a short period of time. Just call it throwing sparks, see what catches the fire. And like you said, it might be for one kid, him to have appreciation with the laser engraver or develop a small business with the 3D printer. I have a kid in school, he talks about his 3D printing business all the time. And I was just, blown away by it. But that's even like right before the Christmas break, the kids got to bring home their projects. And I'm like, look, guys, you're going to have family, friends, whoever come over. You're going to have Christmas dinner. They're going to ask you about school. And you're going to be like, oh, it's good. I'm like, look, you don't even have to say anything. Show them what you built and how you built it, in shop class. And you don't have to say anything. This thing speaks for itself. So for me, middle school, I'm just exposing the kids to tools, machines, technology, that they don't do in their other classes. Maybe they never even knew it existed.
That's cool, awesome. Man.
Nice. Nick, how do you handle the creativity within the parameters of like keeping it organized,
I have to be organized. No, I just that's the thing. Like I don't have a curriculum as far as, state curriculum or anything. And between my woodworking, my metalworking, video and audio, the drafting, and then design class, I just try to involve them and expose them to so much. And, just like Duke was just saying, see what sticks or see what sparks it for some kids. And it may, I've had many administrators come in during my woodworking class and say, how do you do it with all these kids, bouncing around on machines? And I would much rather see that than everybody doing the same project all at once. It keeps my day interesting. It's hell on as far as, remembering back to what last time I talked to them about their project and everything, but I find it much more interesting and getting them to want to learn on it themselves or spark their own interest and have that drive to want to do more. That's the way I've been going lately, last few years, before everything shut down type of thing. But before that, it was definitely by the book. But
sometimes the chaos is better.
Yeah.
You just kind of like, I have a kid that won't stop bothering me about learning the lathe. So I was like, all right. I was like, okay, you can learn the lathe. And I was like, okay, but you got to start with the wood lathe. So I start them off. And because the wood lathe, they can't really mess it up, they're not, and also it's pretty straightforward as long as they don't get the tool caught in between the rest and the thing and I'll pull it in,
Mm-hmm.
So I show them the wrong way to do stuff as a precautionary. So I'll let the tool slip right in there and I'll show them the worst way to do things on purpose so that they realize, oh, okay, wow, this thing is dangerous, But once I've got some sort of comfort level with them, little side projects and breaking from the norm is not bad. And then the kids are so creative that it's like, it's unbelievable. Like I let that kid loose on the milling machine next. And I don't know why, but he started by I let him use wood first because it doesn't grab and it doesn't ruin the tools, And so he made this out of a piece of wood. He made what he thought was like a couch, like a model couch. And I was like, okay, whatever. Then the next thing he made, this was crazy. The next thing he made was he hollowed out a section and then on all sides. And then so it almost looked like the wood was made with tubes and there was nothing in the middle because he hollowed it out that he could take the middle section out. I was like, why did you do that? And he, like, in a good way, he's like, I don't know. I thought it'd be cool. And I was like, it totally is cool. Like, I never would have thought that would be something that he could learn the milling machine by doing, So you're right. The chaos is good as well,
You call it chaos, Ron, but there's, you hear the sound of the tools, the machines and everything else. But you know what? If you really listen, they're not talking because they're working.
Yes, that's true. Yeah. Exactly.
That's the best. You hear it and it's loud, but you're like, you know what? Nobody's talking right now. They're all working.
Mm-hmm.
It's like when my colleague has woodworking and I have drafting class. I can hear it down the hall. I'm like, oh, that didn't sound right.
Oh yeah, shop teacher ears. I could be.
Yeah, that was one of the things that I thought was great, not just in middle school and high school, but in college, was the competition thing. And then you just kind of give them a set of parameters and a goal. And it's like, I don't really care how you do this, but this is what you need to do. And here's some tools. Here's how you can do it. Or, here's what these tools do. Go. Come back to me in a month and we're all going to compete. So, like, I don't know, we did like a solar oven. So it's literally just how hot can you make this oven? And it can only work off the sun.
That's awesome.
I don't care. And it was all about material. Who can use the least amount of material by weight and get it the hottest? And there was a little formula that you could plug your material weight and cost into and your temperature into, and whoever had the highest number, rating won. Same thing with a water wheel. We had a water wheel. Who can use the least amount of water to lift the most amount of weight in the least amount of time?
That's strength to weight ratio challenges is my favorite. And I don't know why it took me so long to get to that point in my career where that is my absolute focus every single year. I really want them to understand, because basically, if you think about it, if you build a bridge and you add a bunch of material, okay, now you can hold a bunch of weight. But did you really do anything unless you weigh it? That should be strong and light. The strongest bridge with the lightest weight, the strength to weight ratio. That's everything. That's it right there.
So that's kind of where we're so the situation that I'm in is, I've been doing all these things with my son, building drift trikes, and even my older son, he built a custom bike, and he welded a bunch of cool stuff to his bike to make it look all crazy and whatnot. And then their friends like it. They like to see it. They like to see what's going on.
Before I forget,
Yeah,
this is the thing that the kid made.
Oh yeah, that is cool.
I didn't ask him to do this. He just he decided that this would be and I was like, okay, well, you're kind of out of the chuck a little bit, or the vice. I was like, you're gonna break it. He's like, no, I'm gonna go really slow and I'm gonna feel it. And I was like, okay. And a girl got in there too, and that's the best part, is that he was learning the feel of the feeds and speeds on his own.
That's huge.
Yeah, so that's what he.
It's like you've given a screwdriver to somebody that's never used a screwdriver, and they're like, like the screwdriver's like this, and it's slipping out, and they're all like, "What the hell am I doing?" And it's just, you have to learn the feel of a lot of different tools, and then once you've been shown that, then you need to be given the opportunity to be creative. The Pinewood Derby Car is a great example of that. We did that, and we did CO2 car racing, which is something I was thinking of trying to do with my son and his buddies, is just build a CO2 car track and then race on it, and just have like massive competitions and whatever. But
absolutely.
I'm trying to.
Here's the lathe project. This was, I think this came after what he did there, and now I got a mini lathe just hooked up to a table. So I said, hey, make this thing, and I had like some samples sitting there. So they're measuring it, and then everything's on their own. I gave them a video to watch a little bit. I keep it close to me. That's all. I'm like right next to them. My computer's like parked right next to them, so I'm like checking attendance and listening to the machine, and works out. They're making chips, and they're getting experience. So it's good. Okay, so you started doing this thing with your son at night, right? You're kind of making like a little shop class.
Well, yeah, I mean, it was just kind of whenever we had time, weekends, nights, whatever. And he's been watching Colin Fures. Have you seen him on YouTube? Yeah. And so he watches a lot of those videos.
Center of the earth right now.
Yeah. So this is my son building his drift trike. He saw this drift trike on Colin Fures' channel, and he goes, I want to build one of those. And I says, okay. So we went on Facebook, asked people for who's got an old crappy bike they don't want, and so they gave him a bike, and then we got a used alternator, and we converted the alternator into a DC motor, and used that to power it. So we tried to do it on the cheap. I think we had a total of like $50 in the whole thing, scrap metal, and some of those gears I think we bought used, those sprockets and stuff. It's like $50 to $75 for everything. Everything else was stuff we already had, and so he wanted to build that, and so we did. And this is just one of many things he did. One of his chores is to brush the dogs, and so he was getting annoyed with having to take the fur off the brush. So he made a self-ejecting fur dog brush, and he 3D modeled it in CAD, and then we 3D printed it, and he used that for his science project. That's actually on my Instagram page. You can see a picture of that after you're done looking at this.
I love that.
It's just stuff like that. And so his friends, I think if you go to like
this,
maybe that thing, yeah.
Whoa, cool.
So there's like multiple pictures of it. I think there's even some videos of it. So he drew it up in PTC Creo, and it's got a little mechanism that when you push down on it, I think there's a video that shows it. And
wow,
it just kind of pushes the dog fur off the brush, and then it just drops into the trash can, and then you don't have to. So there's a dog. And,
I remember doing this. It was horrible. You have to like pick you got to pick. It's just gross.
Yeah, so I think the next video shows the ejection of the dog fur. And then he actually used this as his engineering project for middle school, and he went all the way to SARSEF, like
Whoa,
it
it
was a
worked.
state competition. So he still uses that thing. He uses it all the time.
That's awesome.
And then you don't have to pick the dog fur off. So just
Wow.
literally stuff like that. And then then his friends see it, and some of I want to do whatever, and so that's kind of where I'm at right now. I've got him willing and wanting to do all kinds of stuff, and then I've got some of his friends, like one of his friends' sister. She has a science fair project. She wants to build this mechanism that turns off your shower for you after 5 minutes to conserve water. So she's going to solder together a board with a timer and a mechanism. Oh, that's just screwed up 3D print. You know, sometimes the 3D printer goes crazy.
Yeah.
That's what happened to him, and
Duke
so
knows.
it's just kind of like, just showing the process of it. So his
Gotta
friend's
keep an
sister,
eye on
she
it.
wants help. Yeah. So it's just, just trying to help. I've noticed that there's a lot of kids that are interested in doing stuff, and a lot of parents come to me, and his friends come to me. Hey, can you show my kid this? And can you do that? And I'm thinking, it'd be kind of cool to just do maybe just a little shop class here in my neighborhood or where I live and see where it goes. And then I'm thinking, well, how do I do that? What kind of project should I do? And should I even do this? Are kids going to get hurt and I'm going to get sued? Should I, so I'm just kind of like, there's all these things in my brain that I'm thinking this would be awesome to do, but I've never done it. I'm a mechanical engineer. And I can show my son all kinds of stuff, but when it comes to other people's kids, I'm not sure. I don't know how to make that next step, or that I should. I would love to.
Yeah,
I'm just kind
you
of.
should.
I'm. You see what I'm saying? I'm just not really.
Well, we spoke about this, and there's many ways to skin this cat, but clearly, I think you understand the design. Of course, you understand the design process, but you understand it applied to kids. They need a like a baseline and a challenge and something in between. You're not always going to get that kid playing with the lathe or the mill and doing it in a safe way. That was like kind of like a side special project, But if you're dealing with a crowd, the shop teacher, I told you this before, but I think it's good to record this, is the shop teacher, in my opinion, has three problems. Problem one is you have expensive tools. Okay. So you can't just hand over like some power tool to somebody who doesn't know how to use it. Okay. The second problem you have is all your material costs money. So clearly I give the kids wood before I give them aluminum. I don't even let them know aluminum is an option until they've used the wood, And then the third problem every shop teacher has is the liability of a kid getting hurt. Now, any project you design, and it is a design process because you got to try it out. Any project you design in your head and you try out, it's an experiment. If you could reduce one of those three things, so if you're playing with wood on a lathe, well, then the material's not a factor, gone. But you're still dealing with expensive machine and expensive and liability of the kid. So now, can you take it down another level? Can you get it to something maybe handmade instead of a power tool? So I always step it back and try and reduce your three liabilities. Those are the three things that I think every shop teacher has to worry about. Once you've got that sorted and you can kind of mitigate that, the sky's the limit. You could do a lot of cool stuff. And you always want them to outsmart each other, not outspend each other. So like, for instance, that solar car you're doing, if you have access to, a lot of money, it might not make the difference because, you put this huge motor on there. Oh, great. But now you're going to need bigger panels. Oh, they don't fit. So you're always trying to reduce. And reduction, you can't buy reduction. There's no way to buy it. You have to do it. You have to be creative. There's no way to buy creativity. So any challenge you do with them, you always want them to try and the creativity. They can't just outspend each other, or they won't win. And they'll recognize that right away. Like, just as an example, I do a flashlight project where kids have to make a flashlight, and then we drop it 5 feet, and then they pick it up, and you got to turn it on, and then you got to weigh it. Okay. Now, what people do automatically is they think big box is going to survive. Even though I said 5 feet and I wrote it on the board, they think, oh, Mr. G, I'm going to make it 10 feet. This is going to be the toughest flashlight ever built. And I'm like, cool, great. Yeah, go for it. And then they make this huge box. And I say, okay, cool. Put it on the scale. And they're, and it's like 200 grams. And they're like, yeah, it's 200 grams. And I'm like, all right, you know what? You want to know what last year's winner was? And they're like, what? I'm like, 7 grams. And they're like, oh, garbage, start over, and proudly. Now, if I had told them, this is where you avoid the friction. If I said, hey, that's too big, this is my opinion. My opinion is, and I'm the boss here, my opinion is you need to reduce that box size. It would be like, no, I'm making the box. You don't understand. I'm making the box because I'm making it tougher. So you'd have this argument. Never get into an argument with someone who's trying to be creative. Just let them know the rules. The rules are lightest flashlight that still survives the fall wins. Not my opinion. The scale is who you got to talk to. Don't talk to me. Talk to the scale. And that's where they're not going to argue with you over stuff. They're going to get super creative. They're going to be like, all right, okay, so last year's winner was 7 grams. I'm going to do 6 grams, So that's my 2 cents of how to run these projects. And it's so creative. I mean, whatever you come up with is going to be like an experiment, and you're going to change it the year after.
I can't tell.
Go ahead.
Ron, if I can't tell you how happy it makes me to hear that kind of approach from the seat of education taking place. It's absolutely pivotal to our future success in every single skilled trade facet, that we are encouraging people to find their own solutions. That kind of the kind of knowledge that's untrained, it's an untainted data set because it's not influenced with bad habits. These people don't grow up knowing what's not possible. So they imagine a larger set of possibilities than you and I perceive in our reality. They organically, naturally perceive this wide world of possibility until they learn from physics and laws of nature the reasons why some of those ideas won't fit. But they bring that creative edge that you and I can't touch anymore because of the knowledge that's been compounded and in many ways pounded in. My education was very much regimented. It was very much curriculum oriented. I had a handful of teachers who thought like you did. And looking back, they were the most influential educators in my history because they had more of this free form approach where they were willing to let us approach our ideas on our own terms and then learn about ways to either support and reinforce those ideas with facts and history, or to discard those ideas and to help them. They helped us evolve our way of thinking. Your mindset and approach to this, and the freedom that you've somehow gained of having a lack of curriculum, that makes your educational environment like so super relevant to the way that we have got to be teaching the next generation. The most important skill we need in the field, in any technical field, is independent problem solving. We need to be teaching kids how to think through solving problems. So the curriculum, while there's an importance to it, like the creativity of how to arrive at their own solution, that's what's most critical. So I celebrate everything that you're talking about, leaning into that chaos environment, leaning into that, letting things go off the rails a little bit, that free form. It's so crucial. And Rocky, it's crucial that your kid is learning how to solve problems in that independent nature on their, I mean, it's a vital skill set. I celebrate everything about that mentality and approach. Cheers.
Nice. Yeah.
Thanks.
Thanks, Brant. Yeah, this is good. I'm in a lucky position where there's no curriculum and a lot of shop teachers are kind of there, but yeah, you evolve it over time. And I encourage Rocky. I think you could totally do it. You're going to don't do everything at once, you know, approach it like a design problem, you know, try out something, see how it goes, you know, add a little more. The kids will tell you too. You can even have these conversations with them, which is surprising. You can even say, hey, these are the rules. All right. What do you guys think of the rules? You know? And then they're like, well, you know, they'll make a suggestion. Like, we had one kid one year, he wrapped the flashlight with tape. And I said that I had to be able to see into your project. I have to see, because I had a kid one time buy a flashlight and put it inside, and you know, so I don't want them outspending each other, you know, or they can, but that won't help them. And so I want to be able to see in, so I have to have a window or something. And this kid wrapped it up. He said, hey, look, that's a wall, and you can see past this one thing. And I go, that's interesting. You know, does tape count as a wall? And so we had to have this conversation about it, you know, and they'll talk with you about it. And they care more about the rules as well, which you'd be surprised about. So I said, look, if I take tape out of the rules and I say it has to be something semi-rigid, it can't be tape which takes it's like a film. It can't be a film that takes the shape of whatever you're covering. That doesn't count as a wall in this experiment or whatever. You might lose, but we're going to make the rules better for everyone. And this kid was like, do it. It's okay. And I was like, really? He's like, yeah, it's all right. I get it. I was like, okay, are you sure? And he's like, yeah. So I had this conversation. So the kid lost, but he understood that that we're trying to make the rules better for everyone. So they're on board for this experiment with you, which is like mind blowing. You know, like it's not that teacher thing where it's like us versus them. Hey, you got to memorize this thing. Hey, memorize this thing, and then I'm going to ask you to write down what you memorized. You know, like what? Then yes, it is a us versus them, and they are going to try and cheat. You know, cheating is just part of it. They're absolutely going to try and cheat, because what is the point of memorizing this thing? But when it comes to creativity, there's no possible way to cheat. It's impossible to make a 3D object that you cheated on unless you stole it from another kid, which they're not going to let you do that. Even the softest kid will not let you take his project. It's just not going to happen. It's too much invested in it, you know? So, yeah, so I think you could run these experiments, and I think you got what it takes. This is very good that you're doing this. I was going to go over to Al. Al, we didn't get to ask you, how do you run your class? Like, you know, is it something like this? What do you do?
It's I have more of a curriculum. I teach 5 of 9 sections of design and drawing for production. So it's a drawing class mostly. And I'm looking forward to going back, because before we left from break, the kids used what was it? Inventor, which is so strange that I didn't know Inventor before this year. And I don't know it a lot, but I know so much more. And so I'm really happy to have learned that this year. But they had to draw plans. They had to take a concept sketch of a tea light holder that one of the guys in the department made up. And we gave them the concept sketch, and then we gave them the working drawing with more information. And they had to take that drawing and turn it into the CAD file. And one of the problems I had to solve was it's what is it? The joint is going to be a dado. You guys have seen this before, right? Where you cut, it's a 3x4. I don't have anything with me. Oh, but I do. It's a 3x4 piece of wood. This is going to be hard to show, I think.
All right.
This is the that's the working drawing, and they had to figure out the length of these dados. The note says confirm dimension in prototype. And, honestly, it took me a long time, and I'm not even 100% sure if I'm thinking about this right, but because I didn't do the plans. But I kept telling them, well, you got to go check out one of our prototypes and see what the measurement was. And I started thinking, I'm like, well, that's really dumb, because they're not going to get anything by just going and looking and measuring something and finding out what the answer is. So a lot of kids came up with a couple of different answers, seemed to work. But then just before we left for break, I'm like, wait a minute. That's saying that when we build something and we design something, that we have to confirm our measurements before we go into mass production. So the note was, check in the prototype phase. So then they had to turn it into a drawing. What is this? Delvin. So this is what this student turned in for his drawing. I haven't graded them all yet.
And these are hand drawings?
No, this is an inventor drawing. So they had to take this and they had to turn it into something like this. This one's not 100% complete. It's missing the isometric. But they had to read it. I'm looking for.
That's good. I mean, they're learning about, the industry standards, reading a drawing.
Yeah, reading a drawing and then creating a drawing so that it can be understood by somebody who wants to build it. So I'm looking forward to going back because actually that's going to be their first physical project they've been able to make this year. All the jigs and fixtures are ready to go. I just have to do some table saw safety. And I found a couple of really cool videos. There's a guy who wasn't focused. I forgot the guy's name. I'm going to take just part of his video, 5 minutes of it, because he talks about what happened when he cut his hand, because he was looking over here and he reached over to get the cut off, and you can see it happen. And there's some gore parts, like he shows his hand in a bandage and that sort of stuff. But I'm not going to show him that. I'm just going to show him this other thing. And the key thing I want him to take away is focus, even though I think it'd be really hard to hurt themselves with the jigs and fixtures that were made for these projects. It's still important. So I'm looking forward to going back on Friday and starting that.
Yeah.
So I don't think I answered your question though. So I would love to be able to do it the way that you're doing it, Ron, and others are doing it. But because of the curriculum for this particular class, I have to go through and hit certain points throughout the year. And we're going to give a midterm this year and a final.
It makes sense because it's probably part of a bigger picture, right? Like once they take this class, then they can go on to another class you guys have there.
Yeah, it's the first class. Then after that, if they're going to go through the engineering academy, the next class is a CAD class where they'll get exposed to different CAD programs, 3D printing, problem solving. They have to, one of their first problems in that class is they have to design a pen and draw it out in Inventor, or I think it was a choice.
Nick is the pen master.
Yeah. So
he turns pens. He's got a whole turning kit and a way of. He even reined me in. I was wild when I was doing my pen, and it was. I made the stupidest pen, and he was like, he would ask the vital question. He said, he didn't say, like I said, you don't want to argue with a student. He didn't say, hey, don't do it like that. He said, how are you going to sand in between those ridges you made? And I was like, oh, yeah, he's right. He's like, make it shallower or make it more reasonable. So then I cut off all this nonsense I had made. But it was a very good question. Sometimes all it is a question, You just never want to, don't try and design things for the kids. You just never want to do, or any student. I'm a big kid. You never want to go like this. You just want to be like, hey, look, are you sure you want that target? And they're like, oh, that makes them think, when it comes to the computer program, I'm online this week and I didn't want to have too much downtime. So I actually use a program called Onshape, and it's a PTC thing. And I don't know if this would appeal to you, but basically it's SolidWorks, but it's SolidWorks with like the same ability you have when you're sharing a Google document. You can work on the same. You can work on the same file at the same time. You can even watch someone work on it. So with my advanced kids, we're just like literally with no measurements, we are making a small engine. So one kid made a piston. He's never made anything like this before. I started making the block. There's a kid making a gear for the cam gear. There's another kid making a tappet. We're just kind of goofing around, and we're going to get the measurements as we go. But what's cool is that if they were on here, I could actually see them working, and that's the assembly. But then each one of them, this kid's working on an intake valve. This is going to be the cam gear. He's missing the cam part. Another kid's doing a connecting rod, and they're all together, and it's all online. And you don't have to have a powerful computer because it's literally a tab on the website here. I don't know if that works out for you. Then for my intro kids, I'm doing I just do a donut. I call it the cyber donut. And what we do is we start out with, I call it Tony Stark's cyber donut. I don't know why I was getting into Tony Stark when I made this, but what I do is I have the kids make a donut, but then they got to take a bite out of it. And in order to get that curve in the bite, they would have to do a revolve for the donut, but then a revolve cut, which gives you the jaw pivot, which is so stupid, but it means something when you're designing something, And what's great is if I can see everything they've done, and I can also make changes or help them. So they're not on right now, but I would see them, and I could see their mouse move, or they could watch my mouse move. It's a very good teaching tool. And I think you can get pretty advanced with it if you wanted to. So this is another thing. I don't know, Al, if that appeals to you. Some people get crazy, and they'll put the icing on it.
Yeah, what's interesting about OnShape is that I knew it sounded familiar. There's PD in February that my department head said, to all of us, hey, if you need CTLE hours, you should consider taking this because we might be using this in the future. So I forgot all about it. It goes for the rest of the year, starting in, I don't know. I think I'm going to do it. I need to have a class. Like I can tinker and play around. Like I found some things in Inventor, figured them out because I've used some CAD before, but I do need a structured class to sort of get me into something like this. That's the kind of learner I am.
Oh, that makes sense. Yeah. They also have this feature that I've never seen before, and they call it the Enterprise feature. So, and it's free this year. I'm sure they're going to charge schools next year, but I can look at activity. So I can see everything that's happening, anything they've made, show changes. So they made the change here, here, and here. I can see everything that every kid is doing and every move they made. So there's no way to cheat, and there's also no way to say, oh, I can't do it or whatever, because I could see what they did. Or not that you need all this level of security and oversight, but I gotta tell you, it's interesting. So, like, for instance, here's the analytics. Let me see. I think this is my activity. It'll tell you how much time someone spent. I don't know where exactly I'm just getting to learn this thing, but it's built for schools. This version, this side of the website, they call it the Enterprise. It is built for schools, and they're willing to work with you. So even Chris, or Rocky, if you wanted this, I don't see why they wouldn't hook you up, even though you're not a school. I could see why. I could see them doing that. So this year they're being generous, and they've got support. You can get somebody on the phone, and they'll help you out, whatever.
Does this have any kind of, is it just a 3D modeling program, or does it have any kind of analysis capabilities?
Okay, good question. The analysis, I think, is an aftermarket thing you have to do you have to go to their store and see. Then you can download or integrate any one of these. So simulation, I guess. There you go. And I'm not sure which one comes with this or which one you have to get, but there's a lot of aftermarket going on here. And the same thing with the cam. That was a good question. Here's Mastercam connected. Free connector to desktop. Oh, I think you can use it. I'm not sure. Yeah, I'll have to ask about that. That's a great question. I actually have never done Mastercam. I would like to do that. So, as a teacher, you don't, clearly you don't know everything, but you got to learn, So that was a good question. Yeah. Whereas, SolidWorks, a full license comes with simulation, right? It's got FBA. Yeah. Cool. That's pretty good. All right. Let's see what else is going on here. So now we never asked you about your career. I know we did give us kind of like got into the career, but we didn't talk about some of the stuff you're doing. Can we talk about what your role is at Raytheon?
Yeah.
I don't want to know the codes, the launch codes, or anything like that.
Yeah, I don't have anything like that.
Yeah.
But yeah, after college, I went to work at one company for a couple of years, Sergeant Controls in Aerospace. We did a lot of spherical bearings, hydraulic actuators, like mostly like landing gear type mechanisms and things like that.
Mm-hmm.
And that was pretty interesting. I learned a lot there. But I've spent most of my career at Raytheon. I did 15 years. I just finished up 15 years in December. And so there, my career has ranged from designing. It started off as in test equipment, where if you need to, when you've developed a missile, so everything we make is missiles and missile systems. And so when you're doing aerospace applications and defense applications, you have to do a lot of qualification testing, and you have to subject your stuff to different environments to show that it's okay, and that it'll survive, and it'll go through all the things you need it to go through, flight vibration and exposure to temperatures and all the stuff associated with being in a battlefield situation. So all the test equipment needed for that, I would design. So, like for example, you have to simulate flight vibration or hard shocks, like 400G, gunfire shock from a tank or something like that. You have to simulate those things. So I would design the test equipment that would do that. So you hold on to something.
Test equipment as well.
Yeah. So I started off there, and then I moved over to
You work with Iron Man? Are you Iron Man?
You got me. No. So then I moved on to developing. So a lot of the missiles use for their seekers, which is basically the eyes and the brains of the missile. They operate in different wavelengths. So they'll use like RF energy, IR energy, that kind of thing. So you have to develop all the mechanical things associated with the sensors that take in information in those wavelengths and then communicate it to the rest of the system. So from a mechanical standpoint, for example, if you have an optical system like an optical gimbal that's operating in the infrared, so it's basically looking for a heat signature, it's a very precise mechanism that has to point very precisely because you're trying to find a target, an airplane or a tank or another missile or whatever. You're trying to find a target from very, 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 very far, far, far away. And so you have to have super high precision optics and little motors and encoders to steer the gimbal and look in different directions. And so it was my job to take that mechanism it's got telescopes and all the optics and things like that on a gimbal or on, whatever mechanism we need to point it in the right direction. And all these optics are machined down to, so you guys are used to machining things down to like thousandths of an inch, plus or minus 10 thousandths, maybe 5,000, something like that. Well, these optics are machined down to angstroms, which is like atoms.
What?
So you have to, when you're dealing with super high precision optics like that, like the James Webb Telescope that just went out.
Oh, yeah.
I mean, that thing is unbelievably precise. Those mirrors are ground down to, super high precision. So all of our optics are that way. And optics.
Just to interrupt you for a second, I've been telling people that this is an underrated situation. This James Webb Telescope situation. They're downplaying this. This is massive. Am I right that this is not appreciated? What's happening, right?
So if you think about a telescope, right, you just kind of think about, well, there's Galileo or some pirate or something, and he's got this thing, and he's like, look over there, and it's so to see what, for example, the James Webb Telescope is trying to see requires so much precision. It'll blow your mind. So, for example, when you're dealing with like mirrors like that, when you're dealing with just the mirror by itself, each one of those little panels is one mirror. To grind it and then coat it and then polish it down to the precision that they need takes super, super, super high precision tooling, such that, like I said, you're worried about angstroms, and you have to worry about a single speck of dust getting on it. You have to worry about temperature change. So if you were to, for example, okay, let's say you're holding on to one of those panels, those mirror panels, and it's going to go through temperature cycles, whether it's exposed to the sun or whether it's exposed to the cold, whatever. It'll relax, it'll change shape, right? Because it's thermally expanding. There's a thing called coefficient of thermal expansion. And so things are changing across temperature. Well, that's great if that panel is just floating in space all by itself. It can expand and contract all at once. But you have to hold on to it. You have to bolt that mirror to something else.
Oh, yeah.
And that something else can impart distortion onto the mirror. And now this image that you saw is distorted along with it. And when you're trying to look light years away, if I hold a pencil tip in front of my face and move it plus or minus 1 inch, that's one thing. But if I move it plus or minus an inch way, way far away, then it's harder to see those little subtle movements from far, 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 far away. And so you have to be able to be super precise with all these mirrors. So, and also cooling, the detector associated with that is probably a cryogenically cooled sensor detector.
Oh, wow.
So you have to deal with that, and
they say
it's very complicated.
So if one of these panels is being held by something else, and then that thing has a different thermal expansion rate, then the two could fight each other.
Right.
Yeah. Now, what's interesting is this show has done a lot of talk about thermal management, and especially when it comes to houses. And they have this phrase, my favorite phrase of the whole year, the thermal break. And that's what they got right here. These like wind sail things on the bottom, I was doing some research on it. It's so that when the sun hits the bottom of it, first layer gets rid of the super hot, the second one gets rid of another one. It's like a radiator. It's trying to thermally break that sunlight coming out of there, because otherwise you could heat this thing up every time the sun hits it.
So that's effectively, you take something like that, not quite as big and gnarly and as expensive, but that thing is gathering photons from light that's light years away. So, for example, I would argue that without getting into too much detail from a missile standpoint, you can see a soldering iron from 10 kilometers away. And so
Really?
that type, but you can't get that kind of precision unless you can't get that kind of sensitivity without super high precision. Then you couple in all the environments that you have to live in. So this James Webb Telescope is out in outer space. There's really no forces imparted on it other than its travel out there, right? It has to survive the actual leaving the Earth's atmosphere. But in a missile standpoint, you've got flight vibration, you've got temperature swings inside of a bay of a F-35 aircraft. Maybe the weapon is out on a wing, and the wing is vibrating. It's one day it's in super hot, the next day it's in super cold. Some of these weapon systems have to survive gunfire shock. So how do you take something super precision and then hold on to it mechanically, allow it to survive, and allow it to not really be disturbed by the mechanisms that you create to hold on to it itself? So, like you said, if you've got a telescope, you can't just over design it. Going back to your bridge analogy, yeah, I could sit here and I could literally I could encapsulate my telescope on a missile in a vat full of concrete, but that's ridiculous. I can't fly. It's too heavy. It's all these things. So that's the part of engineering that makes something challenging. I can over design anything, but how do you make it to where it's the cheapest, the lightest, and it still works and it still survives? That's where the engineering and the science and the physics comes in. So my job at Raytheon up till January of this year, because I'm actually leaving Raytheon, it is to design systems like this to go into the front side of a missile and find its target and then survive from a mechanical standpoint. So I design all the gimbals, all the mechanisms that hold the mirrors and the optics. I've also done some, they call them control actuation systems. So the fins on the missile, the fins that steer the missile places. So all the mechanisms that steer the fins. So you've got 40 Gs that you have to withstand.
Whoa.
These guys will move pretty quickly. So you have to design all your mechanisms to survive all that. So it's a lot of things that you guys are probably familiar with. Brushless DC motors, optical encoders to tell you where you are. Bearings, all these things that a lot of people are familiar with. But how do you apply that into a very highly stressed environment and high performance environment, where you have to make things like this optically work, but structurally survive? So that's, and then also a lot of, I see a lot of, we do a lot of.
We got a hand up. We got a.
So the other thing that's a lot of fun is flight testing. So you get to blow stuff up. You get to go out and you launch a missile at White Sands Missile Range or whatever, and you get to watch it blow stuff up, or you can be out on the nose of an aircraft and you can blow up a tank, so we get to do a lot of testing of those things too.
So
See,
cool.
that's my thing, Rocky. See, that's the part where I can't quite wrap my head around this, because this engineering, the precision, the depth of this is phenomenal. It's feats of human strength and ingenuity. So here's the question. How not you necessarily, but you collectively, how does your group decide where to draw the line for how sophisticated to make this thing, which is ultimately going to blow up? Like we're blowing it up, right? It's just going to blow up. So how do we decide, like it? Because like you said, you can over design all of it. You could over engineer every last bit of it. How do you decide where the line is for, pun intended, bang for your buck?
So that's the beauty of what Ron described earlier. Is it always boils down to, and Ron didn't come out and say it, but what the result of the way Ron teaches is money. So if it always boils down to schedule and money. So the DoD, Department of Defense, or DARPA will say, wouldn't it be cool if I had this missile that can go after this target? And oh, by the way, I want to buy 1,000 a year, and I only want to pay $250,000 per, and it needs to live in these environments. And so you have this shopping list of things that it has to do. And so your goal is to, as a company, your goal is to design something that will do what they want, meet their price bogey, and not just meet it, but do come in under so that you can make money. So ideally, you'd want to satisfy all their requirements and their time and their schedule and their budget, and you'd want to do it for as cheap as humanly possible so that your company can make money. And that's how you decide how far to push it. And as you can imagine, the hard part is actually doing that, because it's really easy to be super expensive, but it's really, really hard to be super cheap, or sometimes to even meet the price or the cost that you've maybe bid in the beginning. So I'm also involved in a lot of that. The customer might come and say literally exactly that. There's a shopping list that the customer comes out with to all the Department of Defense companies, and they'll say, I would love to have these kinds of technologies. And then you can go and you can read through it and you can say, I bet you I can do that. And why don't you give me, I don't know, $250K and a year and a half, and I'll do like a feasibility study, and I'll tell you, I could probably do this, or I'll tell you, it ain't going to happen. And then you go and invent, and you create, and you do a bunch of analysis and 3D modeling, and all these things that you guys are showing these kids, really comes in handy, because they'll know, okay, well, I got these kinds of fasteners over here, and I got to bend sheet metal like this, and I got to do this and that, and you're doing all this in a 3D world and using PTC Creo or whatever software you're using, SolidWorks. And then you come up with something that maybe will work. Maybe you'll build some prototypes and you'll break them, and then you'll learn. You go again, and then at the end of that first contract, you might say, "Yeah, look, I've built something. It works in a lab." And then you'll go and ask for, okay, well, for another, let's say 10 million, I'll build you one, and we'll go fly it, and we'll go beat it up, and we'll go make sure that it works, and then we'll go fly it and test it. And then you just kind of iteratively kind of see where it goes from there. You just keep iterating until you get to the point where you're maybe at a low rate production program, and that's how. All while the requirements are changing most of the time through that whole process. So I said that you'll try to meet those requirements as cheap as you can, but over time, as your design matures, you have to be prepared to say, listen, I'm not going to be able to hit that. This is what I can actually do. Does that still work for you? Can you still live with that? And it's a back and forth thing. So that creativity part of it is super important, because I can't tell you how many times that people have just designed in the box, quote unquote box, to say, well, we've kind of done it like this, and I can't tell you how many times I've had really sharp, well-educated people, engineers, physicists, come out and say, this is how it's done. This is how we're going to do it. And then, somebody that is completely divorced with the program, they have nothing agnostic to this program, show up and they're like, why are you doing it like that? Did you ever think about this? Something completely different, something completely out of left field. Oh, okay. And then you kind of start building on that. So that ability to recognize where something can completely be different is super important and super critical.
How much of the failures from like your prototyping, your testing, and your attempts end up informing innovations for your next design? Always.
A failure is not a failure is, I always tell my son and anybody even at work, if you're not failing, you're not getting after it. Like, you have to try stuff. If you're not, that's why you have to prototype. You have to prototype quickly, and you have to learn quickly. And of course you should do your math. Of course you should do your calculations and your analysis. You shouldn't just go out and, on a whim and just try stuff arbitrarily. You have to make some educated decisions, but you also shouldn't allow yourself to fall into the whole paralysis by analysis, which I'm sure you've all heard, type situation where you're just sitting there grinding and let's run another analysis, let's run some more equations and just squeeze a little more blood out of the rock. But at some point you just have to go and test. And so I'd say, as far as a percentage goes, we typically will get to a point where our analysis tells us with, I would say like 70%, I would say with 70% confidence that we'll be successful. And then we'll get on to this next level, because everything's tested in levels. You'll test at a subassembly level. Okay, the whole widget consists of 5 pieces. We'll test piece 1, 2, 3, 4, and 5 all individually, and then we'll learn about how they work. Oh, this one's not quite working. Okay, well, oh, that's why. And then you go put pieces 1 and 2 together, and 3 and 4 together, and then you test those together, and you just kind of keep moving up. So at every level, you're always failing. That something will always fail, guaranteed. But there's at least, I would say, 70% confidence level that before you even go on to that point of failure, that you're close enough to where that failure isn't going to blow up the whole program. I mean, you're in the ballpark. You just have to do some diagnosis or whatever the case may be. And it could be a structural thing. It could be an electrical thing.
Do you go so far, Rocky, as to track the rendition process itself to try as a company to get faster at your successful time period to a functional prototype? Like, are you analyzing it to that extent, or are you more or less, is the process just aggregated to a degree where you have to exert a certain amount of effort to get results? Or is Raytheon interested in like shortening the rendition and cycle time to a functional prototype? Do they analyze the process to that degree? Because that's what I'm trying to do with construction. I'm trying to like analyze process time for solutioning and like get faster at that specific aspect of arriving at functional experimental prototypes for inventions and innovations and things like that. Are you guys looking at it from the same way, or is there an expected time frame of the process that's generally accepted overall, or do you guys try to aspire to shrink that window?
So we do that with, especially with programs that are already mature. So if we have a program that's got some legs already, we've been building it for a little while, maybe we've already gone through like a low rate initial production, then we will absolutely go through some optimization to try to make that process quicker, better, faster, and then we'll document it so that future programs can reference it. In fact, I just did that late last year. There was some newer programs that were coming on. I thought to myself, oh, this is a lot like this other program. Let's go talk to these people and look at their metrics to say this is how long it takes to do this, and this. You can leverage that for future builds.
You apply that at the manufacturing stage mostly, but not necessarily the innovation stage. You don't try to rush the innovation side.
The innovation part of it, we will try to document a little bit of that, and then use it for future reference. But I will tell you, that's hard, because when you're building something from scratch, it's never the same, although it can be similar. What you rely on is experience. And you can go back and you can look at the numbers and you can say, oh, we spent 2,000 hours developing this widget, and this other thing is kind of like that widget. So we'll just say it's going to take us 2,000 hours. That sometimes will work, but I will say that most of your time and money and future success of the program is baked into what level of effort you put in the very beginning. So if something is truly very similar, then yes, you can do that. And we do track numbers for that. We do track hours, how long it takes to develop things. We have contract numbers that we can pull up and say, and do that. But a lot of what upper management might try to do is to leverage that knowledge and say, oh yeah, we can do it, 2,000 hours, piece of cake. But then you get down into the weeds and it's like, well, this is different, and it's different in these subtle ways, and those are the things that are going to bite you. So it is a challenge. It's a definite balancing act. To answer your question, yes, we try it, but it doesn't always work out with the development part of it. But with the right team and the right group of people that have done it in the past, you can normally at least estimate what it might take, and you can understand what optimization you might be able to go through to make it shorter. If that makes sense.
Last question, and then I'll let Ron take back over his podcast.
No, it's fine. I enjoy this. I like it's a participation. Absolutely. That was a good question.
Sometimes when you see when you see interviews with astronauts and people who've actually been into space and been past low Earth orbit, the interviewer's always asking them questions like, when you watch space drama on TV, how much of it is realistic? I just got to know, when you watch the Iron Man movies, do you look at those things and go, nah, that's ridiculous? Or do you look at that and go, yeah, I think I could do that next week? I mean, like, where are you at on the spectrum here for missiles popping out of your shoulders and shooting 60 targets at once? Where are we at with that?
Yeah, I think especially when it comes to Iron Man type stuff, a lot of that is a bit much, but there are definitely things that movies come out with that are considered when you look from a defense standpoint, that when you're talking about hitting specific targets or traveling at certain speeds. I mean, I don't know if you guys have seen a lot of the hypersonic missiles that are coming out right now. They've been in the news. You can look them up on YouTube and things like that. So when you're talking about hypersonic weapons, traveling at speeds that are very fast and surviving that, that's pretty impressive. As far as, like Iron Man's suit, that just ain't gonna happen. Like, that won't happen. But some of the weapons and handheld devices, I don't know if you guys are familiar with directed energy. That's like a non-lethal form of, for example, crowd control.
Oh.
So it's like RF energy that's concentrated that you can use to like I said, crowd control. But it's basically a way of,
it's microwave weapons, right?
Inflicting pain but not killing someone. Right. For lack of a better term. So
good idea.
So you can basically focus energy down, and you can do things like that. So that kind of thing. I mean, you're talking about, there was a company here in Tucson that was developing directed energy for use in battlefield situations, where you would send out a sacrificial ATV that had these arms that would swing out, and you would basically electrocute the ground along the sides of roads to detonate roadside bombs. And you would send that out ahead of a convoy in Iraq or wherever, or Afghanistan or wherever you are. And this thing would basically sweep the side of the road and detonate bombs. And then, of course, that thing would die, right? It would explode. But at least your convoy knew, I'm good to go, at least up until the point where that thing died. And then you send out another one.
Yeah. Wow.
So that's all with directed energy. And so there is some cool stuff that's fairly accurate, but I think a lot of it is definitely fantasy.
Interesting.
Thanks for indulging me on that, Rocky. I'm always curious to find out if fiction is informing design or if design is fueling fiction. So
I actually do believe that there are some things that movies come out with that technology ultimately catches up with. I mean, you think about our smartphones, you think about, some of the cars that we're coming into right now with electrification, and there's a couple of, like, are you guys familiar with Archer? Archer's coming out with a personal, you seen that one?
Yep.
Oh, what is that?
So Archer's making they're trying to become like the Uber of aircraft. So you can have like a vertical takeoff little, like, I think it's like an octocopter or something like that. So instead of taking an Uber somewhere, you jump in this thing and you can fly from rooftop to rooftop for a little bit more money.
Yeah, first flying car was unveiled yesterday too. Yeah.
Yeah, that's it right there.
Whoa.
So the next company I'm going to go work at, I start on the 24th, is called Too Simple. I don't know if you guys have heard of them or not.
No.
So they do autonomous semi trucks.
Oh wow, that's going to be a big deal.
So they're it's all self-driving semi trucks. So self-driving cars and
Yeah.
stuff like this.
What'd you
I
call
think
it?
a lot of that.
Simple?
Yeah, too simple. TU simple.
Rocky, you've come a long way from shop class, baby.
Yeah.
Yeah.
Oh yeah, self-driving is going to be massive. Yeah, this is going to be a game changer. It's funny. I have a lot of I'm a big Tesla fan, and the one thing that always came, I mean, now nobody even questions Tesla, but people used to get so upset, and they would tell me that I've wasted my money because I invested money with it, and they said, they would say, well, it's GM's going to make an electric car, and I'm trying to explain to them, Tesla's not making cars. They make smartphones with AI tech and self-driving tech, and then they call it a car. It's not a car. That's the problem
Right. They're making an ecosystem.
Yeah, this is not a vehicle. A vehicle is like like a 65 Mustang. That's a car. That's not what Tesla's making.
Right.
It's a computer. It's a computer on wheels. It's literally just this, with the Apple personality, but yet they're using space tech. I just don't think people realize that it's not a car, although it looks like a car. The analogy I have is a phone, like the ones we used to rotary dial up. That's an actual phone. This is not a phone. This is a computer that pretends to be a phone and everything else. So Same thing with the Tesla. A Tesla, yeah, there are cars, and then there's Tesla. Tesla's not a car. Tesla's a computer that pretends to be a car just for a temporary amount of time. Wait till they get rid of the steering wheel. Then you're going to be like, oh, it's a computer. I'm like, yeah, I know. I've been telling you this whole time. Here's how you know. They asked Elon Musk about the steering wheel, and his answer was like so scary. His answer was, any input is error. That's his opinion.
But from a coding and mathematical standpoint, he's exactly right. I mean, you have to account for all errors, and the more inputs, the worse off it is. I think you just got to get to the point where you trust the technology and that the technology has proven itself. So these guys here, they just compete. This Too Simple company just on the 22nd, they just completed the world's first driverless trek in a semi truck.
Really?
From Tucson to Phoenix.
Really?
Yeah.
Interesting. And is it they're just using like a diesel, and they're autonomous?
Yeah. So this is agnostic to the platform, right? It's all about the autonomy. You can do whatever truck you want. Right now they're using diesels.
And that's
but the
fine.
idea is to come up with a network.
You got to get started. It doesn't matter if it's even if it's diesel, it's going to be more efficient if it's running on autonomy. I would assume.
Yeah.
Interesting.
And they're just they're just focusing on the long haul stuff, the stuff to go from 2,000-mile runs that a lot of people don't want to do anyway, and then that final trek from let's say it reaches some warehouse in Phoenix and you live in South Phoenix, and and a human will take it the rest of the way. So that's kind of their goal here. But I think a lot of the things that you guys are talking about, I'm looking at Albert's drawings and things like that. I mean, all these things that you guys are talking about from a shop class perspective, they're all pertinent to everything that I do and have done my entire career. I've been an engineer for almost 20 years. And, the drawings, it's unbelievable to me how many brand new engineers show up and they can't read a drawing. They don't know what tolerance stacks are. They can't do a tolerance stack. They don't know what the tolerance block means. They don't know what the notes. I mean, it's so hard to understand. Colleges aren't teaching that. Some of them are. Don't get me wrong. Some are. If you take a machine shop class, they'll teach you the fundamentals of drawings, geometric dimensioning and tolerancing. They'll teach you some of those fundamentals. But to me, it's like that's the language of especially of a mechanical engineer. It's like you can't even speak my language. You show up to my doorstep and I have to like show you the language. It's ridiculous. You know, one of the things that got me my very first job was the fact that I had an associate's degree in automotive technology. When I interviewed for that job, my boss, Gary Spangenberg, said, "Congratulations, you got the same degree that everybody else has. Why are you different?" And it had everything to do with the fact that I had built a solar car. I had an associate's degree in automotive technology. I had built hot rods and muscle cars and low riders and monster trucks, and had lots of experience with turning wrenches. And I had things to show him that I did that. And that was the thing that set me apart from everyone else. That's why he hired me. Fast forwarding 3 years from there, it's the same reason I got the job at Raytheon. Guy told me the same thing. Yeah, you have some experience now, but he liked the fact that I had some hands-on experience, and all the things that you guys are teaching. It just goes so far, especially when these new hires show up, and you're asking them to design machines and mechanisms. And we're talking mechanical here, but even electrical. I mean, there's electrical engineers show up, systems engineers show up, and they have no idea how to put together a circuit card, or how to solder, or whatever. You know what I mean? Everything is so conceptual. And some of the best engineers I've ever worked with are people that had some level of experience in the field, in some other industry, or at least did some internships, or participated in other projects. So it's super important what you guys are doing and showing these kids. And if nothing else, it's giving them some confidence in themselves to understand that, hey, I could fix these things, or I could build these things. I don't have to be intimidated by, whatever little thing I might be interested in. Maybe it turns into something, maybe it doesn't. There's a young woman right now that I'm helping her. She's 12. She's a friend of my son's, and she asked me to help her build this little mechanism that turns the shower off for her science fair project. And so she showed up with these, like, she went to a local company here in town, and they gave her all these little resistors and capacitors and things to build a timer mechanism and buzzers and all. She had no idea what to do with this stuff. And at the end of it, we're soldering boards together, and I'm showing her how to put all this together. And I said, everything that you're learning right here in this little board is all around you. In this TV remote, I took apart my key fob on my wife's car, and I showed her the circuit card. I said, "Does this look familiar? This is exactly what you're making right here. Look, there's a resistor. Look, you're putting one on right there." Mm-hmm. And she was just grinning ear to ear, and she's saying, "I love doing this. This is amazing." And to me, those kinds of activities are super important. And I applaud you guys for being so involved with that. I think it's great. So
no, it's really, really good to hear. I remember the first time we spoke, we talked about, you said that your hands-on experience has really helped you move up in your career. And, like, for instance, I got a student that he was going for mechanical engineering, and he wanted to be he wanted to work at Tesla. And I had an opportunity to help him get a dealership job. And I said to him, "Listen, this is a good start." And he did not have an ego about it. He never said like, "Oh, well, that's the dealership. I don't want to fix broken Teslas." He easily could have said that, and he didn't. He said, "Okay, so I'm going to work there, and then I'm going to prove myself over there. And then I'm going to keep getting my engineering degree at night." And that's what he did. He got a dealership job, diagnosing the cars. Now, Tesla has a culture that if you come up with a better way to do something, they're all ears. So he kept making the process efficient. I'm not sure what innovations exactly, but they took notice, and then they actually sent him on flights around the country, putting out fires at dealerships that either that local person didn't understand or couldn't do the process. From there, they hired him in the prototype division in California, and from there they sent him to Nevada. So now he's kind of like a traveling engineer, and he just got started.
That's awesome.
And there was no, oh, I don't want to touch the car. Absolutely was ready to learn how to fix broken Teslas. I remember I even called him because my friend, he bought a Tesla and the heat didn't work in the middle of the winter. They have not anymore, but they had a sensor that was like a whole, almost like a recall, but if you brought your car in, they would fix it. But I texted him about it. And he said, I think it's this problem. They're aware of it, but they don't have a solution yet. He was on top of it. He knew that car in and out, And but going back to what you're talking about, those fundamentals. Here's something interesting. This is kind of weird. This is like a big breakout board. It's a 555 timer. And Rocky's like, yeah, I know what a 555. I didn't know what this thing was, but apparently this is in everything. Like, this is the number one chip. Obviously not this large. This is like, instead of an integrated circuit, this is what it would take to make this circuit. But the 555 timer, which basically every speed control has it. Like, every computer in the world has this 555 timer. It's the most popular chip. I didn't figure out. I'm in my 40s. I'm just learning about it now. But the building blocks to make something, the resistor, the capacitor, your 555 timer, the relationship between these things is this. It's like you're just learning about your paint on your canvas. You're like, okay, I got red, yellow, blue. These are the things you're going to paint with, and absolutely should be taught. It's so funny that for some reason, like, soldering a board became like this bad thing, and they're not teaching it as much as they used to, which is crazy.
So that's the other thing I wanted to mention is, I had no intention of becoming an engineer. I wanted to build race cars, and I don't want anybody to think that that's the end all be all is to go on 4-year university and do all, because there is 100% nothing wrong with doing any kind of other trade or any kind of, I'm not going to lie. There's been times that I've been at work thinking to myself, I would much rather be a welder or much rather be a machinist or something like that, because I love those things. And don't get me wrong, I enjoy my job. I do like engineering, and it's got, it's kind of encompasses all the things that I enjoy. But, some of the greatest people I know, the most wealthy people I know, are people that are in the trades. And, I know plenty of people that are plumbers, electricians, roofers, I know a guy that's a welder, and the guy makes more money than I do. And so I don't know how the whole stigma became about, where it's like, you got to go to college, you got to go. And I do agree that it is important to go to college, or at a very minimum, you need to, whatever path you take, you need to become great at it. So if you're going to be a plumber, you need to go get certifications. You need to be really good at it. You need to get trained up on it. If you're going to be a welder, same thing. You're going to be a machinist or a carpenter or whatever, you need to go get formal training, and you need to be great at it. If you take those paths and you go on to 4-year university, then that's cool too. But, if my son told me tomorrow, or, when he's not tomorrow, the guy's 13, but if he told me when he was, 18, 19 years old, hey, listen, I want to go to trade school. In fact, he really wants to go to the one of the high schools that is just down the road from us. They have a lot of trade courses there, which they don't have at his middle school. So they have welding, they have an auto shop, and he's like over the moon about it. He really wants to go. And they offer college credit for it, and they actually offer certifications through that high school. I'm all for it. And if he wants to eventually go to 4-year university to be an engineer or something else, then that's cool too. But I don't know. I think that learning to work with your hands is a lot more than just, I can fix stuff, or I can build things or whatever. It's very enlightening, on multiple levels, and it just gives you confidence about all kinds of different things about yourself. And I think that's super important. And whatever it turns into is whatever it turns into, as long as it's positive and you're doing good stuff with it.
Yeah. Just to add to that, the flip side, I found, there are people that when the word engineering comes up, not just trade, there's also this allergic reaction to engineering. Whoa, I don't want to be an engineer. You know, they like get nervous. And I was one of those people. I remember I thought it was just big, scary math, you know, I didn't know what it was. And even my niece, you know, I said to her, hey, you know, take some engineering classes while you have a chance because you're in high school. And, you know, she, and along with a lot of other kids, would say, oh, no, I can't do that. I don't want to do that, you know? And well, what do you want to do? She's like, oh, well, I want to be a nurse. And I'm like, okay, well, isn't that kind of like, it's like a mechanic for humans. That's basically what you're doing. And she's like, oh, no, I'm not going to be a mechanic. And they put this wall, there's a division between engineering and trades and like what they're doing, which is they're not doing that. They're doing medical. And I'm like, well, so what's the first thing you do when a patient walks in? Do you guess? And she's like, no. And I'm like, what do? You like probably take a measurement of some kind, right? And she's like, yeah, we probably take blood pressure. I'm like, okay, so that's same thing. What are the symptoms when the car rolls in? What's the problem? Let's measure it. You know, what's the first thing you're going to do? We might put the computer on it, or we might take a look at a sensor or something like that, you know, or whatever it is. Let's look at the symptoms and what are those symptoms associated? What tests can we run? I was like, you're a mechanic. And she's like, no. She got so upset. I'm like, yeah, you're a mechanic. Yeah, but for people. And then if you want to be an engineer, that would be like biomedical. You're figuring out how to make the process of fixing the people better. You know, so now you're not just fixing the people, but you're fixing how they fix the people. You know?
Yeah, I think the other thing is we talked about this whole divide that's put up, is the divide that kind of naturally tends to occur between the engineer and maybe the technician or the person that maybe the operator of what the engineer has made. So you'll get like, you know, I see it all the time at work. The operators that are there building the missiles. Oh, the engineer designed this. These guys are idiots. They over-design everything, and they don't know how to put it together, and they don't know any of these things. And so it becomes like, you know, the engineer is just this person that's just all technical and nerdy guy that sits there behind his computer and makes everything as, you know, ridiculously complicated as possible. Then there's the other side of it where the engineer is like, well, the technician, those guys are a bunch of grease monkeys. They don't know how to put anything together. I have to like hold their hand and I have to do all these things. And most of the time it's because they don't ever come together. They don't ever meet. I mean, the engineer never turned a wrench, and the wrench never did any kind of design work. Everything's over-designed. Everything is just that. I'm just going to throw boatloads of wood at it, or metal, or steel, or screw. You know what I mean? So it's never overlapped, because once you do that, you can really learn to appreciate what the technician that has to build this thing that you invented, how it goes together. And the tech has to appreciate, okay, well, why is this thing the way it is? Well, it has to survive all these environments, or have to do certain things, because they work well and close together. They have to. I mean, unless the engineer is also the guy that's building it, which is very rare, and vice versa, the person building it is not always the engineer. So it really does help to have a little bit of experience on both ends from both people.
Yeah,
I see that all the time.
Yeah, agreed. I try and convey that to a lot of the students. Even the medical kids, they say, "Oh, I'm not going to go into engineering. I'm going to be a doctor, or pre-med." I'm like, "Okay, aren't you going to use a robot for surgery?" And they're like, "Yeah, probably." I'm like, "Maybe you should take the robot class. Just take the class. Just find out what they're doing.
I think you really nailed it, Ron. You talked about rebranding the opportunity, separating the opportunity from the title. And in the process of that, you rebrand. And this is crucial for the future. We've got to rebrand the opportunity that's available as independence. Because the truth is, the more you technically educate yourself, the opportunity that's there is for you to gain independence. If you learn plumbing in high school, you don't have to call a plumber when something goes wrong at your house. If you learn electrical in high school, you don't have to call an electrician to install your ceiling fan. If you learn auto mechanics, you don't have to call somebody to do your oil change or to save you from the side of the road. You're gaining independence from that knowledge. If we could just rebrand it to some degree to where the next generation understands that what they're gaining is not just skill in one specific title or category, but they're gaining an independence of problem-solving capacity. I think we get more people on board.
Yeah, I agree. I think the word engineering, I love it, but I think it scares the crap out of people. And it's just, see, we got to do something about that. I call it a measurable benefit, but that's hard to convey. It's a mouthful, Well, this has been real good. We'll probably leave it here, I think, Rocky, you got what it takes, man. You're a shop teacher. Bam.
Appreciate it. Thanks, guys.
You've been stamped. Okay. Now, whatever you end up doing, stay in touch. If you come up with let's say a plan, and you want us to talk about it, or you want to ask questions or whatever, and probably we'll learn from you. So if you come up with something, share it with us, and we'll steal your idea and try it out with our kids.
Yeah, I was just going to ask that if I could bounce some ideas off you guys. I have a few. We'll have to talk another time. One thing I wanted to mention, totally off subject, Ron. I learned yesterday from my sister and her husband that they took your welding class last year.
Get out of here! Really?
Yeah. Yeah, it was like she was telling me all about it. She was telling me all about this. I think they did it for their anniversary or something. And he was like, she goes, wow, because she was talking to me about, you should teach people shop class. You should teach people how to weld and do these things. I took this great welding class from this guy. And, man, he did this thing where he poured water on a table and he pulled the water puddle over, all this stuff. He was great. And then when you and I connected, I asked them, hey, who was that guy you were taking? And then it was you. I said, you're kidding me. So, yeah, small world.
That's amazing. What's their names? What is the couple?
Yeah, Susie Hernandez and her husband is David Lawrence.
Oh, I kind of remember them. Are they in one of my videos? I think she actually let go of the hammer. She was hitting it. One of them hit, like there was a couple. She was hitting it, and I made the mistake of letting them have the glove on when they were doing this. My policy is the glove is off, that they'll feel the grip. But anyway, so that's something you learn in a shot. And she hit the thing, and then she let go, and it sent the hammer like right down the hallway. It was amazing.
I don't know if that was it, but she did say that her husband had a hard time like setting down the arc welder or something, and it would keep arcing on the table.
He was a guy who literally, like, every time he'd be like, okay, cool. Like after he's done, he'd be like that, and we'd be like, whoa. The table's hot, man. The table is hot. So it was not even just me. Everyone standing there would grab his hand, and he kept on doing it.
Yeah.
But
I thought that was interesting.
It's fun though. We have a good time. The first time he did it, it's like, whoa, we got flashed. The second time, everyone just grabbed his hand.
So she kept telling me how great of a job he did. She's like, yeah, you should follow this guy because he's got great information. And if you're going to do a shop class, he's got a lot of great ideas. And now here we are. So
that's awesome. That's so cool to hear. I haven't even counted up. I must have taught, it must be 250 people intro to welding. I don't even know how it got like this. I literally started doing this because somebody had asked me to teach bicycles at like a green fair. And then another person said, hey, can you teach anything else? And I was like, I probably could teach you like basic welding, like on a little setup. And I just started doing that. And then it just grew from there. Oh my God. That's so funny. That's great to hear. I across the entire country. I can't believe that. That blows my mind. That's crazy. Good to hear. All right, so stay in touch. We want to hear what you're going to do. I'm very curious because I think you got good ideas and clearly you know what you're doing. So, yeah, we'll help you out. And Duke is a middle school specialist, so he probably. I mean, I deal with the high school kids, but if you're going to do like kind of your kids sound like it might be in the middle school range, then Duke's got a ton of experience with that.
Yeah, look me up.
Yeah, I appreciate it. I will.
Cool. All right. All right. We'll leave it there. Thanks for spending the time. It's awesome.
It's
And
been fun,
as
guys.
always,
Thank you.
I come out of this stoked. Like, I'm excited. This is awesome. All right. Well, we'll end the recording right there. Shop Class Podcast Wednesdays. I don't know if we have a guest yet for next week, but I think Matt's working on it. He's got a alumni coming in maybe. All right. Thanks a lot. Shop Class Podcast, and we're out.